Section 11.2 Types of Chemical Reactions. The objectives here: be able to describe the 5 general types of reactions and predict products of these 5 general types. Alright, here's the 5 types that you need to be familiar with. They are combination, decomposition, single replacement, double replacement, and combustion. And you need to be able to look at an equation and decide which of those 5 types it would be. So let's take a look at the first one. The first one is a combination reaction. A lot of times I call them synthesis. That was what I learned them as synthesis reactions. But basically, we're talking about putting things together, combination or synthesizing. We're putting 2 things together and we're creating one. That's kind of our key thing that we want to look at, is we start with 2 or more substances and we form one. Okay? Form a single substance. That's the key thing that you're going to look for anytime that you suspect it might be a combination reaction, is you're going to form just one product. Here's an example. You can see that we've got 2 Mg plus O2 yields 2 MgO. Now I don't care what these numbers are. That's not important. What I care about is the fact that we've got 1 here, 1 there. So we've got 2 different reactants. 2 reactants. That's my key. And we have 1 product. So if I take 2 things, make it into one, that is a combination reaction. Doesn't seem too hard. You should just be able to look for that. 1 product. That's kind of the key thing. There's none of these other ones that we have that you're going to have just 1 product. So let's take a look at a couple of examples. These are out of your book on page 330. And you can see we've got 2K plus CO2, 2KCl. Once again, 1 product. Or sulfur plus oxygen yields SO2, 1 product. Or a different combination of sulfur and oxygen and a different product. But even though there's the numbers are irrelevant. We're talking about just one thing formed here on this side. If you need to see more, take a look at page 330. There's a couple more there for you to look at. I would like you to do these problems. So we're talking about combination reactions. So take a look and figure out what would happen if you get beryllium plus oxygen, and figure out what would happen if you got what would take to form magnesium nitride. Okay, it would actually be, yeah, that'd be right, magnesium nitride. Alright, so stop the video, go ahead and do this. Alright, so if you look up beryllium, you'll see beryllium is a 2 plus, because you got to figure out what the compound is that's going to be formed. Beryllium's 2 plus. Let's work that over here. Beryllium's 2 plus. Oxygen is 2 minus. Some of you probably just said, hey, well, put it together. Well, it just doesn't work quite like that. What it does do, this is a 2 minus. What it does do is put it together so that these balance. 2 plus, 2 minus. The correct formula, that 2 was not there. The correct formula would be BeO. I know you want to say, oh, well, we trade them, but when it's a 2, we can't do that. So it's BeO. So that's what's formed, BeO. And then when that's formed, now you have to balance the equation. You cannot go back and change things. Though this was the product that's formed. We know that. We know that's correct. Don't change it. Don't add a little 2 to it or anything like that. At this point now we got to go back and balance. Well, look, O's are not balanced, so I'm going to come over here. I'm going to put a 2 there, and I would have to put a 2 there to balance that. Alright, so let's look at the next one. It says formation of magnesium nitride. So what we're saying is we want something plus something gives me Mg3N2. Well, there's only 2 things. So it's going to have to be magnesium and nitrogen, and we just have to make sure that we get it in the right form. Remember, nitrogen is a diatomic, so it's going to be that way. Magnesium is just an element that's monatomic, so we don't have that. And now we need to balance. Looks like there's 2 nitrogens and 2 there, so we would need to put a 3 there. Make sense? All right, let's go on. The next reaction is kind of just the opposite. It's a decomposition reaction. This is where we break one thing down into 2 or more. So we start with a single compound, break it down into 2 or more. Okay, that's the key that you're looking for. 1 reactant, 2 or more products. Here's an example. 2HGO. Okay, 1 reactant. That is my key thing I am looking for. 1 reactant. It gives me 2 products. Could give me 3 if something that was bigger. Doesn't matter. 1 reactant, 2 products, 2 or more. This is decomposition. So here's our key. Decomposition, 1 reactant. That's our key thing. Gives us 2 or more products. In all the 5 that we talk about, there's only 1 of these that has just 1 reactant. That's our decomposition one. So look for that. Most of these, they're going to require some type of catalyst, something to get them going. Usually some type of energy. Might be heat, light, or electricity. So a lot of times you'll see written above there, maybe it'll say heat or light or something like that above the yield sign, because it needs some type of catalyst in order for it to happen. So here's an example. If you take water and you run electricity through it, you can actually separate it into its elements. Well, so let's do that. So what's the elements for hydrogen? We've got hydrogen. The formula for hydrogen would be H2. And then oxygen is also diatomic. It would be O2. So H2 yields, or H2O yields H2 plus O2. Not balanced yet. We're going to have to balance. We'll put a 2 there, and we would have to put a 2 there. Okay? I want you to try these 2 right here. Stop the video and work on those problems. Alright, so hydrogen iodide, or hydroiodic acid, if we're talking about it dissolved in water, would break down into hydrogen and iodine. Hydrogen, we said, is H2. Iodine is also diatomic, so it's I2. And we need to balance it, so it would look like that. Alright, next one. What decomposes to give you H2 and Br2? Well, we know we're going to get H2 plus Br2. And there aren't too many things that we can get when we put those together. So let's see. Hydrogen is +1. Bromine is -1. Together they would form the compound HBr, hydrobromic acid. And we would need to balance it. So it would look like that.